This is a tutorial for tutorial question 1 from tutorial 2C. We are asked to this question comes in three parts. The first part asks us to express this fraction in partial fractions. So we do partial fractions like we usually do. Because there are linear factors on the bottom, I don't have to worry too much. I assume that r over r plus 1, r plus 2, r plus 3 is equal to a over r plus 1 plus b over r plus 2 plus c over r plus 3. And then I cross multiply to both sides. That tells me that r is equal to a times r plus 2 r plus 3, since the r plus 1 term would cancel out, plus b times r plus 1 r plus 3, since the r plus 2 term would cancel. Oops, what am I doing? Plus, yikes, plus c times r plus 1 r plus 2. Right? And the wonderful thing about this, as I said earlier, this is not an equation, this is an identity, so that means it's true for whatever values of r I substitute in. So I can pick values of r that will slowly cancel off some of the terms, so I might say r equals to -1 then, and so I'd get -1 on the left hand side. I'd get a times -1 plus 2, which is 1, -1 plus 3, which is 2, plus b times 0, because this bracket would be 0, plus c times 0, because this bracket would be 0. And that tells me that a is equal to -1/2. What about if I set r equals to -2? Well, then I'd get -2 is equal to, and then I'd get a times 0, because this bracket is 0, plus b times -1 times 1, plus c times, this bracket would be 0, so c times 0. And that tells me that b has to equal to 2. And finally, I could set r equals to -3. Then what do I get? I get -3 is equal to, and again the first one, a times 0 plus b times 0 plus c times -2 minus 1, and that tells me that c is equal to -3/2. So at the end of the day, what do I have? I have r over r plus 1, r plus 2, r plus 3 is equal to, let me just factorize out -1/2, so make things slightly easier, then 1 over r plus 1 minus 4 over r plus 2 plus 3 over r plus 3. And so that's the first part. Right, so the next thing I have to do is I have to show that this is equal to this. And obviously well, maybe not obviously, but they're trying to give us a hint by getting us to write this in partial fractions. So what they want us to do, what the question wants us to do, is to use our partial fractions to replace this horrible expression inside the summation. So the summation from r equals 1 to n of r over r plus 1, r plus 2, r plus 3 is equal to the summation from r equals 1 to n of -1/2, 1 over r plus 1 minus 4 over r plus 2 plus 3 over r plus 3. We can take the -1/2 out the front, and then I can write down a few terms, and sorry, I never leave enough space, so I'll make sure I do this time. And we can try writing out a few terms. So when r equals to 1, what would I get? Well, r equals 1, I'll get 1 over 2 minus 4 over 3 plus 3 over 4. Okay, that doesn't help very much. What about if r equals to 2? So I get plus 1 over 3 minus 4 over 4. And notice that I'm still leaving it over 4 here. I'm not simplifying it too much. Plus 3 over 5. Still can't see anything yet. Let's try one more. r equals to 3, I get 1 over 4 minus 4 over 5 plus 3 over 6. And again, maybe just one more so that we can definitely see it, although I'm sure you may have seen it by now. I'd get 1 over 5 minus 4 over 6 plus 3 over 7. So can you guys see how this row, a quarter minus 4 quarters plus 3 quarters, these three terms would sum up to give 0. And similarly, these three, 1 over 5 plus 3 over 5 minus 4 over 5, these three are going to sum up to give 0 as well. In fact, I'm going to get cancellation going across the diagonals. How long will it go on for? Well, I should write out the last two or three lines here. I'm a bit lazy, so I'll write out the last two. So when n equals to n minus 1, what do I get? I'd get 1 over n minus 4 over n plus 1 plus 3 over n plus 2, and the last line would be 1 over n plus 1 minus 4 over n plus 2 plus 3 over n plus 3. So when we follow a cancellation pattern, what does that leave us with? So we'll only cancel things that completely add up to be 0, so like these three and these three, and then there'd be stuff inside the middle that would cancel out with this lot, and with this one, and with this one, and with this one. So that leaves us with three terms at the start. This, and this, and three terms at the end. This, and this. So what does the whole thing equal? The whole thing equals to still have the negative half out the front, and inside the bracket I would have 1/2 minus 4 over 3 plus 1 over 3 plus 3 over n plus 2 minus 4 over n plus 2 plus 3 over n plus 3. And we're not finished yet because that clearly isn't the form that we want, although it's getting very, very close, which is nice. So what is this equal to? Negative 1/2, and then this is 1/2 minus 4 over 3, 4/3 plus 1/3, that's 1/2 minus 1, that would be negative 1/2. And then 4 over n minus 2, sorry, 3 over n minus 2 minus 4 over n minus 2, that would give me minus 1 over n plus 2, sorry. And then plus 3 over n plus 3. And then expanding out the bracket, I get 1/4 plus 1 over 2 n plus 2 minus 3 over 2 n plus 3. And that is what I wanted to show. So I can stop this question here. So this was actually a method of differences question. Now the last part asks us to hence find the limit of this. So what is this? Well, the limit as n tends towards infinity of the sum to n r equals 1 of r over r plus 1, r plus 2, r plus 3. Well, you can actually answer this even if you couldn't do part 2. This is nothing more than the limit as n goes to infinity of what we just found. In fact, what was given to us in the question. 1 over 4 plus 1 over 2 n plus 2 minus 3 over 2 n plus 3. So what's the limit of 1/4? Well, as n gets bigger and bigger, well, 1/4 is constant. It doesn't change. So no matter how much n changes, I'm still going to have 1/4. What about 1 over 2 n plus 2? Well, as n gets very, very big, the whole thing, 1 over 2 times 2n plus 2, is going to get very, very small. Like if we put in n equals to 1,000,000, then you've basically got 1 over 2,000,002. That's a very, very small number. It's very close to 0. So the limit is going to be 0. And similarly, the limit for this one, it doesn't matter that we've got a 3 on top. 3 times a tiny number is still a minuscule number. So this one is going to be minus 0 as well. So the limit is 1 over